In this tutorial, let's go over how we can animate our coin to look, to make it look a little nicer. So far we have a perfectly functional coin. It technically works, and for our purposes of increasing score, it works. We can collide with it. We only get to collide with it once because it destroys itself, and it increases our score. So functionally, it's all there. We've given it like a little bit of a boost by adding some sound to it to give it a little bit of feedback, but let's do some more. Traditionally, when you think of coins in games, we think of them spinning, and that's something we can do, so let's add that. We're going to add that in Unreal using a specific node called a timeline. So let's just go ahead and look at that. All I've done is I've deleted all the coins in the level. I've just left one just so we can look at it and get an understanding of it. Come back in our blueprint graph. We still have our overlap code. And somewhere else, I'm just going to right click, open up the palette, and I'm going to search timeline. At the very bottom, and always at the bottom, it will say add timeline. Let's read the description together to just get an understanding of what it is. Timeline node allows values to be keyframed over time. That gives us a sense what it is. We're going to have basically a timeline, as the name suggests. We're going to have this thing that moves forward in time, and we're allowed to set keyframes on that, and that we can run things on. So let's add it, and let's give it a sensible name. I'm going to call it spin because, like I said, we're going to have our coin spin as we use it. And there's a bunch of input nodes, a bunch of output nodes. Real quick, let's just take a look at what these are. We'll see some of them as we use it. There's play and play from start. So play just plays a timeline. Wherever the playhead was, it's just going to continue playing it from that. Think of, like a DVD or something, or like a YouTube video. When you pause it, the opposite of pausing is playing it. Next, we have the play from start. Just like play, except it's going to move the playhead all the way back to the start and play it over again. We have stop. Stop is going to stop our timeline and then move the playhead back to the start. Unfortunately, there's no direct way we can pause a timeline. We can only stop it. We have reverse. This is like play, but we're going to play the timeline backwards. So from the max time, we're going to start moving towards 0. Reverse from end. This is like play from start, except instead of moving the playhead back to the start and playing it, we're going to move the playhead all the way back to the end and start playing in reverse. Finally, there's these two nodes here, set new time and new time. New time is just going to be the time that we want to set it to, so our timeline will start at 0 seconds and just count up in time. So if I was to set this to 1 second exact, for example, and then we run this set new time function, it's just going to move our playhead to that. So whatever time we set here, when we fire the set new time event, our playhead will just move to that time. Now, when we look at the other side, we have update. So our timeline is going to move forward in time in seconds. Every frame, this update is going to run once. It's basically just like a tick event. Next, we have this finished. If we look at our for loop again, for example, which has a completed, this is basically similar to that. When our timeline finishes, so we'll see when we get in there, we give our timeline a minimum and a maximum. The minimum is always 0, so it starts at 0. And the end time can be whatever we want. When it reaches that end time, this finished runs once, just like the completed of our for loop. Finally, there's this direction. All this is going to do is tell us if our timeline is moving currently forwards or backwards. It's good to know that it's there. Not something we're going to use particularly, but it's good to know it's there. So before we get into it, let's just think about real quick what we want our timeline to do. We want it to rotate the coin. So if this was the top view of the coin, so my coin is green, I'm just going to... So this is me looking top down at the coin. It's a little cylinder. And I want my coin to rotate like this. So the one nice thing when we think about rotations is if I was to start here and just count every 90 degrees. So we start at 0 degrees. We come all the way down. We have 90 degrees. We go around a little more. And the opposite of 0, we have 180 degrees. Keep going. then we have 270 degrees, which is the opposite of 90, and we come back up and we're at 360 degrees. So 360 and 0 degrees, they're not the same number, but in terms of rotation, they look the exact same. And just like that, as we keep going around, we were at 360, now we're going to be at 450, and that looks like 90 still, and we come around again. From 450 we go to 540, and that looks like 180. Keep going. We're at 630, that looks like 270, and we come all the way back up here again, and we've hit 720 degrees, which looks exactly like 360 or 0. So that's one nice thing about rotations. We can just kind of keep adding it, and it doesn't matter. It's just going to keep looking the same. And so we can use that property to get our coins to spin fairly easily, fairly simply. And let's go do that. I'm going to open up this timeline, and you can see it puts me here in this empty graph area. All I need to do is go up here to where it says track, and you can see it lets me add a couple of tracks. There's a float track. We know what floats are. It's just a number. There's a vector track. A vector is just 3 floats. An event track, so this will let us specify when to fire off certain events based on the timeline. And we have a color track. So a color track, again, kind of similar to a float track, except it's specifically for color. A color track similar to a vector track, but it's for color, not for vectors. So different use. And a color will have 4 floats instead of 3. It has R, G, B, A, and the A is alpha there. So let's just add a float track. That's all we really need. And the track itself can be named. It says new track 0. Right click and name it. I'm going to name it spin. Now, the timeline has a max and minimum length. This is how we can control kind of the speed of the animation. All you need to do to add a keyframe is hold shift and let's just click on the graph. So you can see I've added 2 keyframes here. If we look up here, we can see what time the keyframe is at and what its current value is. Remember, this is a float track, so the x-axis is going to represent time. The x-axis will always represent time. And the y-axis is going to represent whatever we added here. We added a float track, so the y-axis represents some floating point number that we can use. So all I really want is to set the time at 0 for the first point, and let's start our rotation at 0. And our timeline length is 5, so I'm going to set the last point to be at 5, and I want its rotation to be at 360. We can click these 2 buttons that says zoom to fit horizontal and vertical. This just lets us look at our graph nicer. So as you change the values, you can click these always to kind of size the graph back. Next, there are these buttons up here. The 2 important ones to note is autoplay. Autoplay is just going to start playing the timeline when the game starts. I do want that. And we got loop. This is just going to make sure our timeline loops over and over and over again, which is also something that I want. Set those 2 to true. And now when we go back to our when we go back to our event graph, you can see that under direction we have a new float value. We called it spin. That is the exact name of our graph that we have added. And what value is spin going to output? Well, if we look at this timeline here, we know it's 0. Spin is going to output 0. At 5 seconds, spin is going to output 360. And any time in between that, if I put my cursor over here, we can see it tells us. It says so time 1.76, so 1.76 seconds into this timeline, it'll output 120. 2.63 seconds into this timeline, it'll output 186. But really, what we have is this linear increase as time goes along. We're increasing the value from 0 all the way to 360, back to 0. And just like we said, the nice thing is that 0, 360 look the same. So, that's going to work out for us. So let's actually use this. Back in our event graph, I'm just going to make the actor itself rotate. So I'm going to do set actor rotation. And we want to run it on every update. What is this rotation? Well, I don't want to rotate every axis. I just want to rotate I just want to rotate it on the x-axis, but if we look at the rotation here, we can see both the x and the z are rotating. So this is actually one small problem here. That's because I have this default scene root. So I actually don't want to rotate the whole actor. What I want to do is just rotate the cylinder, because that's going to rotate just on one axis. So if I come out here to this viewport, I actually want to rotate it on the y-axis. And here you can see only the y number is changing, so we know that that's where we want to rotate it. And yeah, so I'm going to go back to my event graph, pull out this cylinder, and now I'm going to type set rotation on it. And so you can see, instead of it saying set actor rotation, let's use the set relative rotation. And let's plug that in. We said we want to rotate it on the y-axis, so let's just split this pin so we only have access to the y. Plug that up, and let's go check if this worked. So we make sure autoplay is on, we make sure loop is on. Come out here, and it's rotating on the wrong axis. So let's change that, try different axes. I believe it's the x. And there you go, rotating on the x-axis. I just picked the wrong axes, but the rotations themselves work, which great. And now, you know, from here, if I was to add more coins, instead of just adding it, I'm going to duplicate this one. And I play it. Great, everything rotates. Once it reaches 360 degrees, it goes back to 0 degrees. Real quick, actually, let's just see that working through a print string. Let me just delete everything again, and let me just delete everything again. Let's print our values, you know, just to help us understand. So on update, I'm also going to print this spin value, and I'm going to give it a key again so it doesn't fly down. Instead, it will show us in one spot. So I'm going to call it spin. Come back here. Now when I run this, you can see it's going 0 all the way up to 360 and is back to 0 again. You can see our coin is spinning smoothly, and that number is just going to keep going between 0 and 360, which is exactly what we wanted. So now we have our coin spinning, but if I was to just place a bunch, and play it, they're all spinning together. This looks okay, and you know, for you this might be fine. I just want to make it a little bit more randomized, so they're all spinning just slightly offset, so they're not spinning so perfectly in unison. This might be what you want, which is fine. I would rather have mine spin slightly more offset so they look a little more random. And to do that, we can use, there are many techniques first of all to do that. I just want to make that clear. As with everything we've seen in this class, there are many ways to accomplish the same thing. I'm only showing you one way, and usually I'm also trying to show you the simplest way to do it, because that is the most effective usually. It's not the most optimized, and it might not be the best for every situation, but we can only learn how to do things better if we can do them. So that's what I'm going to do here. I'm going to use this new time value now. Because our rotations are nice and synced up, it doesn't matter where on this timeline they start, they're always just going to keep going in circles. And so let's use this new time. I'm going to set this new time randomly for each of our coins, so they start slightly offset. So what I'm going to do is I'm going to type random float. And when we hover over this, it says returns a float between 0 and 1. So we're going to get a float between 0 and 1. It could be 0.1, 0.2, 0.3, really any number between 0 and 1. I want to increase that range, and the easiest way to increase that range is just to multiply it. Whatever number we multiply it with, that is going to be the maximum range now. So I'm going to multiply it with 360, so it can start anywhere in this rotational scale. And if you, let's just take a quick second to think about why this works. Again, we're returning a value between 0 and 1. So if it returns 0, 0 multiplied by 360 is 0. So our minimum value will be 0. If it returns 1, which is the maximum value it can return, 1 multiplied by 360 is 360. So that becomes the other end of the scale. It becomes a maximum value. If this returns 0.5, which is half, of what it could return. 0.5 multiplied by 360 is 180. And that's like the midpoint of it. So really, any value that it returns as we multiply with 360, we've just scaled the end and we really move the end point up to 360. So now instead of 0 and 1, this value is going to be between 0 and 360. Going to plug that into new time. And to use this new time, we actually have to use set new time. So if I was to come out here and run it, things are still running the exact same, because we're not using this new time function. We're not firing it. So I'm just going to fire it on begin play. So when the game starts, it's just going to set it to some random time between 0 and 360. And it's going to run from there. Actually, and I do apologize, this shouldn't be 360. This should be 5, because our timeline is only 5 seconds, and I want it to start somewhere between 0 seconds and 5 seconds. So I do apologize for that, but the concept still holds. Now 1 multiplied by 5 is 5, 0 multiplied by 5 is 0, so we have a scale between 0 and 5. We are just setting the playhead to start between 0 seconds and 5 seconds. I apologize for the confusion. So now when we run it, everything is nicely offset. And if I was to actually play the game, I could see my coins here. And we could collect. I don't have the score debugging anymore, but now, as you can see, just through some simple code, very little code, we have a spinning coin, makes our game more lively, makes things seem more nice, But yeah, in the next video, we are going to look at how we can display the score to the player using UI. Thank you for watching.